Hello, hi everyone. So my name is Sandeep. Welcome to my YouTube channel Techie-S. So today we will discuss about the data center cooling capacity planning. Means how the cooling capacity is planned in the data center when the data center is planned and when data center is commissioned and established. So its cooling capacity is planned, means how much tonnage of the AC will place in the data center according to the server racks, network structure, network infrastructure, server infrastructure, storage, all the other equipment whatever are running in the data centers. So we will discuss about today for this. There are actually even this formula you can also use in your home to calculate the AC capacity at your home. So we will discuss this, that how this data center cooling capacity is required, means how much tonnage of the AC required in the data center to run the data center, and plus and how you can also calculate the same at your home, that how much AC is required at your home according to your area, because this totally depend on the BTU. BTU is called British Thermal Unit. So we will today discuss on it. So AC which are in the data center, basically those ACs are like these. These are the ACs. Generally, if we talk about, see, these are the ACs. These generally called PAC. PAC means which are used in the data center for the high cooling, and for the one of the cooling to the biggest area in the data center. And it works like this. This is the hot and cold agile systems. In the blue line you can see this is the cooling which is going, or on the back side the red arrow you can see this is the hot air. The hot air is again going to this PAC, and it is getting cooled, and it is coming from here, then here, then again this servers rack are sucking the power, and then after it's these are inhaling the this one cool power air. Then after these are the hot air is exhaling by the this server and racks and its infrastructure. So this is running like this actually. So this we will discuss about today, and this is totally it's called a containment. It's a hot and cold agile. So this is the actually generally hot and cold agile. Actually there these blue lines where you can see this is the cold air is coming on the underside where I'm pinning this one. You can see there are the perforated tiles. Perforated tiles are there. From here the cool air is coming, and these are the your racks. There are your network, server, all infrastructure is there. So from here the hot air is is exhaling by the servers, all those things, and here this cold air is being taken by the servers. So like this the data center environment AC environment runs. So this is generally we will calculate how this all cooling capacity is planned in the data center to run all those things. So I will teach you today this. So now so this is data center cooling capacity planning. So now I am clearing the screen. So how this all thing is calculated? So I will tell you that how this all thing is calculated in the data center. So number one, DC cooling capacity. So data center cooling capacity totally depends on the infrastructure. Okay, it totally depend on the infrastructure, totally IT infra. So what kind of the infra that we are going to place inside the data center? What kind of the infrastructure that we are going to place in the data center? This infra includes your server, your storage, your network. Generally these are the infrastructure, and according to this the other equipments if there are in the data center, like some data center also include the electrical panel inside of the data centers, because definitely there is one electrical panel which is supplying the power to the all the PDU, power distribution unit of the all the racks, so that is also there. Okay, so these all things are there. So how this all thing is calculated? So first of all, actually we have to take the count of our infrastructure, the count of our infrastructure like servers numbers. For example, if I have the 10 number of servers, storage, I have the 10 storage, network, I have the 10 network equipment. I am just taking an example. Now same we have to calculate its BTU, it's a power. We have to calculate its BTU power, not a BTU power, sorry, watts power. We have to calculate the watt power. So one server has 750 watt supply. One server has a 750 watt supply. Then 10 servers, how many will be into, so this is my wattage of server. Okay, now one storage has 850 watt of supply. The total 10 storage is it's 8500. Okay, one network equipment has because these are the small network equipment, so we can say like it's a 350 watt. Okay, the total 3500 watt. So this is actually watts I have calculated. So this total watts, how much it becomes, let's calculate it on the calculator. So total is 7500 plus 8500 plus 3500 plus, this becomes total nearby 19500 watt. This become 19,500 watt. This totally becomes this. Now we have calculated the wattage. Okay, so there can be lot of infra. I am just taking an example. There can be 100 of servers, 100 of the storage, 100 of the network, equipment, a lot of things. But I am taking an example of if you have only 10 server, 10 storage, 10 network equipment. So generally we have to calculate all the wattage of that servers, that how many watts are there. According to watt, then we have to calculate what kind of the BTU those are producing. Basically, there is one point, it's called British thermal unit. That is the heat which is produced by the network equipment. So we have to calculate with that network equipment that how many heats those are producing. So there is one formula. So first we have to calculate the watts. Okay, I hope this all is clear, right? So I'm going to the next screen. So it was total our 19,500 watt. Okay, clear. So we found 19,500 watt. That is our means power requirement to all the infrastructure. So this is our power requirement to all the infrastructure. Now there is one term called, it's called BTU/HR. What it means? It means British thermal unit. So what is this? BTU is actually, one kind of the measurement to calculate the heat which is produced by the electrical components, right? So BTU is the one of the measurement which is used to calculate the thermal, which is used to calculate the heat in the electrical equipment. So what we will do, its formula is BTU/HR. HR means hour. So its a formula is, there is one formula, it's called watt, and here you will see power means watt into 3.41 divided by 12,000. So this is the formula to calculate the BTU generally. Okay, 12,000 is this is the formula actually generally. So this is the formula to calculate the BTU. So we will calculate the BTU. Okay, and 12,000 actually, this is one of the formula. 12,000 means actually 12,000 BTU means this BTU needs at least 1 ton of the AC. This is the general parameter which is used actually. If there are 12,000 BTU in a room, or there are 12,000 BTU in one of the room, that is heat is being produced, then actually for this much, for a 12,000 BTU there is 1 ton of the AC required. So we are calculating this BTU. On this BTU there will be our tonnage of the AC, ton of the AC, that how much is required. So now I am going to the next screen with this formula. So now we have to calculate the AC tonnage, that how much it is required. So what was my formula? It was BTU/HR is equal watt it means power into 3.41 divided by 12,000. So now I will put the value was my 19,500 into 3.41 divided by 12,000. So now this is our calculation of the AC, that how much AC we need. It's 19,500 into 3.41 is equal, the value is 66,495 divided by 12,000. So our result is So actually we need here nearby 5.54. The approximate mainly result is 5.54, means you actually need 6 ton of AC. So this is my AC calculation as per my data center. Hope you all got it. So basically what happens actually when we do a data center capacity planning. So during that data center capacity planning, the AC is calculated also. Okay, how much AC tonnage is required in the data center, and that all AC requirement is depend on the room size as well as the network infrastructure which is required in the data center. So how much that network infrastructure and data center infrastructure will produce the BTU. Means BTU is what? BTU is the measurement of heat calculation, means how much heat those electrical equipment will produce. So we have to calculate each server racks, rack, storage, network. So whenever you buy some of the any product, this data center product, so there is one that there is one document you can download from the internet, or it comes with that equipment. There is mentioned that this equipment will produce this much BTU. So you will have to consolidate all those BTU, and you will have to calculate all those. This is mentioned on the document. This will produce each this much BTU, and its wattage is this. Okay, so what we have to do, we generally have to take all the wattage of those equipment, multiply into 3.41 divided by 12,000. So you will get actually this much of the tonnage of the AC required in the data center to run the cooling capacity. And there is one more thing actually, because data centers are very big things actually. So there is one more technology used. It's called hot and cold agile. Hot and cold agile, as I told you earlier, this is some kind of this like this. See, so this is actually one of the hot and cold agile, as I show you before. The blue arrow which you can see here, these are the blue arrow, these are the blue arrow, these are the blue arrow, these are the blue arrow. This all blue means it's a cold air. So there all the PAC surrounding this, all the this cold agile, those PAC like this. These are the PAC, you can see 1 2 3. So these PAC, what they do, there is actually they produce a cold air from the downside here. Okay, those cold air comes here, those cold air comes here, here, and these are the perforated tiles. These perforated tiles, so here cold air comes, and the servers like this. You can see the inside there is one glass is there. So this is totally, it's called cold containment zone. So this is a cold containment zone. So under you can see there are the blue arrows here like this. So there are perforated tiles. Perforated tiles means from where the air can cross. Okay, so from here the cold air comes, the servers, all the surrounding all the servers and rack, they just suck the air and and leave the hot air on the backside. These are the, you can say this red is the this much hot air, and this much this blue is the cold air. So like this process keeps on continue. These are taking the cold air and leaving the hot air, taking the cold air, leaving the hot air. So this process keeps on continue, so that where all the data center infrastructure can be cool, and and we have to maintain that cooling capacity, because if you will cool down your infrastructure very much, then there is a static energy generates. Static energy means when you will touch some of the any of the hardware, you will get an electric short. So what we will do, we generally maintain this all this cooling capacity, so that static energy cannot be generated inside of this, and your cooling all environment can be cool. So you have to maintain that cooling capacity in the data center. Okay, so generally the basically what happens actually, this cooling maximum it be between 16 this number 2 between of 25. So you have to maintain the cooling capacity between 16 to 25. So if you will maintain it, then there will no electric static current will generate, and this will be very much your data center will be very much good. So like this. So there is one more example. You can see there is also these blue lines are the cold airs. Okay, these are cold airs are being taken, and hot air on the backside is being left by the this rack. And you can see then after this red line, you can see red line is going into the here. See this, then again it going to into the this PAC, and PAC again cooling down the hot air, and it leaving from the, you can see from the downside here blue air, again it leaving the, then again the cold air, and it taking the hot air and doing it cold, then again again the racks are taking that, then again leaving the hot air. So this process continue like this, it continue like this, and these are the PACs generally. Okay, so this type of the process, which continue in the data centers. So I hope everything is clear. If you have any doubt, you can also comment me on my this video. I will make you or clear all those things if you have any doubt. And this is we are talking about the even this is for the data center. But if you also want to calculate this AC capacity for your home, so you can also calculate with the same fundamental that I will let you know how we can do. So same actually, if you are doing the same thing for your home, so I just write here, okay, home AC capacity calculation. So from the home actually, because home is our home. Okay, so there you can calculate the AC capacity, that how much capacity you need for one room. So there is one more formula for the home. In the home, if you want to calculate, so its formula is your in the room is equal length into width. Okay, length into width, and then after multiply by 25 divided by 1000. So this is the calculation of the room. Okay, means this is generally what happened. This is the calculation for the room AC. So in this actually what will we do, we have to get how much BTU is being produced in a room. So your rooms is equal length into width into 25 into this one. So from here actually what you will get the BTU hours by this formula. Room is equal length into width into 25 divided by 1000 is equal BTU. So you will get the BTU that is being produced by one room, and that BTU we will divide it by the 12,000. So for example, if your room is 20 by into 25, I taking an example like this, each room is 20 by into 20 by, okay, this is the room, multiply 20 by and divided by 1000. So this is the BTU. Actually we are calculating this BTU of the room. We are calculating this BTU of the room. So into this 625, it's answer 25 into 25, 625. Then after again it multiply, we have to multiply it with the 25. So this is the BTU, means 15625 divided by 12,000. So this is the BTU basically produced by your room, and we have to divide it by 12,000. Then approximate the AC tonnage is required. Approximate AC requirement of your the room is 1.3 ton approximate. So it is nearby, you can say 1.5 ton. Nearby it is 1.5 ton, we can see, which is actually required, because there is no AC in the market with the 1.3 ton. So you can buy nearby 1.5 ton of AC. So this is your room calculation. If you want to calculate this into your room, okay, how much AC capacity is required in my room, so this is the formula that you can run into your home. Okay, the room BTU is equal length into width into 25 divided by 1000. It will calculate the BTU hours which is being produced in your room, and then after you will divide that into 12,000. Then your AC calculation is 1.510, 1.310, but 1.5 ton nearby this is. So there are two formulas. So I hope this all videos clear to you in the data center, how it is calculated in the end, in the room, your personal room, at your home, how you can calculate. So this is actually total cooling capacity is planned during the data centers, because data center one of the biggest thing. I have taken a very low example, but you can see there are 10,000 of servers, even more than 50,000 of servers are running. So whenever data center is established and planned, so those all things are planned by the architect, the engineers who are very top class engineers. They do all this calculation. Then after on that calculation, they also take some tolerance. For example, my AC capacity in that area is came nearby, I think it was how much, 5.5 ton maybe was there actually. Okay, so they take 20%, even 100% actually tolerance, and they take 10 ton of AC, more than that, because in future we can place more servers in the data centers. Okay, more more servers in the data centers. Okay, so they take that tolerance. Okay, tolerance means always whenever you have to plan, so you have to plan with the sum of the 20%, 50% or 100% with the tolerance, so that in future you can do. It is not like today you need 5 ton and you are just buying a 5 ton. No, you will have to buy at least 10 ton or 8 ton, so that there can be some tolerance. Okay, so this is like all the cooling capacity systems to work in the data centers. So in future we will also see what kind of the actually what kind of the cooling systems which comes in the data centers. This is basically with the regards to this AC actually, but there are the other cooling systems which are optimized, because in this cooling what kind of the cooling systems in the DC. So what happened actually, this is just only the regard to this much electrical component, so it is not optimized. So it will take your more electricity consumption will definitely, your bill will increase. But actually there are some of the, you can say, standard, although standard systems, or one of the optimized systems which are used also for the cooling of the data centers. So there are 3 to 4 systems. We will discuss those into our next video. So what kind of the cooling systems are there in the data center use, which are most convenient and optimized. Okay, so this was our today's video. I hope you all people has cleared, and if you have any doubt you can comment on my video. I will clear your doubts. Thank you very much. I request you to please subscribe my channel. It's a Techie-S, and very much big thank you for your support. Okay, for more knowledge sharing, please let me know. If you want to understand what kind of the video you need, so that I can make you understand on those things. So thank you very much all your support. Thank you very much.